Okay, so let's get started. But before that, let me. I'm just looking for a couple of videos, nice videos about serverless architecture. I will first pull it up. Okay, let me share my screen. Share the screen. Okay. Okay. So what is serverless, right? So serverless means that you're running without servers, right? Where you have servers, like for example um, the project that we did with EC2 instances with RDS and things like that. Even behind the scenes, like RDS or any other service, any other managed service uses some sort of servers, correct? So now, are you thinking that serverless is something that it runs without any servers? No, that's not the case. Okay, so serverless means you don't have to worry about the servers, right? So, for example, when in the example that we took last week, where we built an application, WordPress, we deployed WordPress on EC2 instances. So out here, if you see, this was our architecture, right? So where we had a EC2 instance, a couple of EC2 instances, and then you had RDS. Okay, of course, in RDS, you don't have to worry about servers because AWS takes care of it. Okay, since it's a platform as a service, but at least with respect to EC2, you still had to worry about servers, right? So you still had to decide what is the instance size that you have to choose, and what is the instance type, what is the family that you have to choose, depending on the workload, depending on how many. For example, if my website is going to be used quite frequently and it's going to receive, say, 1,000,000 hits per day, right? Or some websites get million hits per minute, right? And things like that. You really have to plan the capacity in such a way that you have enough capacity there and your servers are able to withstand that load, right? And your servers are able to take that load, and it's able to serve that load properly so that your website is responsive and your performance of your website is good, right? So all of that needs to be done by you, right? Because if you have EC2 instances, because EC2 instance is nothing but a compute, correct? So where you have a CPU memory associated with it, you have some disk storage associated with it, right? You have to ensure that you are sufficiently sized with respect to the EC2 instances, and then you're able to make use of that, correct? Okay, so now let's come back. So now, what is serverless? Serverless doesn't mean that you're not going to have EC2 instances. Okay, you don't worry about the EC2 instances. AWS takes care of it. Okay, where, let me just put some diagram here. Okay, so you have this, the underlying, you have your compute storage network or virtualization layer. You anyways don't worry about the virtualization layer. Even in EC2, AWS takes care of it. On top of virtualization layer, you have EC2. On top of EC2, you have, what do you have? What is the next layer? Operating system, like a Linux or Windows, right? Well, Linux or Windows. On top of the operating system, you have your um, You have your middleware. It's called middleware. Like we installed Apache Web Server, correct? That's a middleware. Again, on top of Apache middleware, you have your application running, which is your actual application or database, which is WordPress in our example, right? So now virtualization layer is something which is managed by AWS, right? In this case, virtualization is managed by AWS. Okay, and then you have the rest of it. All the blue is going to be managed by you, right? Including the EC2 instance, the operating system, middleware application, and everything needs to be managed by you, right? In a normal traditional way. In a traditional way, okay. Whereas in a serverless way, okay, in a serverless way, you have no, you have, I mean, you don't know whether there is an EC2 instance or not. Right? I'll just call it compute or EC2 or compute. Correct. I'll just say compute. So the compute, the operating system, middleware, all these are managed by AWS. Okay, you only have to write your code. I'll just call it application code. I'll just call it application code, right? So if you see in a serverless architecture, you only write your application code. Rest all is managed by AWS. You don't even, this is a black box for you. This whole thing that you see is a black box for you. You don't even know, I mean, what a middleware AWS is running this on, right? And this whole thing is a black box for you, right? You don't really worry about it because AWS is taking care of it. This whole thing is a black box for you. Okay. Yeah. So this whole thing is a black box for you. Okay. So that's the serverless architecture, right? So the reason why, you know, people are using serverless architecture more and more is, the reason is because you don't have to and manage the overhead of this whole thing. You only focus on your code, right? Because that's what your job is, right? I mean, as an application developer, your job is to just focus only on the code, not on the other things, right? Not on the other infrastructure related aspects, including the middleware. I mean, the choice of which app server that I have to choose. Do I have to go for Apache? Do I have to go for Tomcat? Do I have to go for IAS? You don't worry about all of that. So AWS is there to manage all of that, right? At the end of the day, you choose your programming language, what programming language that you want to build your application on, and use that programming language to build your application. Rest of it is taken care by AWS, right? So that's the difference between a traditional architecture and a serverless architecture, right? So let's go back and let's read a little more about what is serverless. Serverless is a way to describe the services, practices, and strategies that enable you to build more agile applications so you can innovate and respond to change faster. With serverless computing, infrastructure management tasks like capacity provisioning, patching are handled by AWS, right? Like all of this, everything is handled by AWS. So you can focus only on writing code that serves your customers. Serverless services like Lambda comes with automatic scaling, built-in high availability, and pay for value-based billing. Lambda is an event-driven compute service that enables you to run code in response to events from over 150 natively integrated AWS services and SaaS sources. Okay, Okay, all without managing any servers. So, so the idea is the USP of serverless architecture is you move from your idea to market much faster, right? And you adapt at scale and you lower your costs, right? Because you're only going to pay for the code that you run, right? You're not going to pay for running the um, running a virtual machine, right? There's one more analogy that I'll give. In the case of traditional infrastructure, say for example, you have provisioned a EC2 instance. And that EC2 instance is, let's say, R5.2x large. Okay, that's the EC2 instance that you have provisioned. So now in your R5.2x large EC2 instance, you see that your CPU utilization is hardly 40%. Okay, but you don't know when the spike will come and when the CPU utilization will become 80%. Okay, in order for you to predict, you don't know how to predict it, right? So in such a case, you want to still take a chance and keep it running at R5.2x large. You don't want to come down from R5.2x large because you are scared that what if suddenly the CPU utilization spikes and your application crashes, right? So in this case, you have to pay for this R5.2x large for the entire duration of what you're running, because you're renting an EC2 instance, you're renting a virtual machine as it is. Whereas in the case of a serverless architecture, you really don't have to worry about it, because you're running a code. Now, your code runs for, say your code runs for 100 milliseconds. Okay, that's what your code runs for. One execution of the code runs for 100 milliseconds. In such a case, you only pay for this 100 milliseconds of compute time. Okay, you don't pay beyond that. You don't pay it for 24 hours, because in this case you're paying for 24 hours, right? In a day, you're paying for the entire 24 hours. Whereas in this case, your code is running for 100 milliseconds. You pay only for that 100 milliseconds for that particular execution of the code. You don't pay for beyond that. Okay, so that's the difference between a traditional way of running your applications versus running it in a serverless model. So that way you're definitely lowering your cost, because you pay for over provisioning, because in this case you're over provisioned, and your resource utilization is optimized on your behalf. Okay, you don't have to pay for that entire duration. Okay, so now let's go into the serverless services. Now AWS has got several services that provide you serverless way of working. AWS Lambda. Okay, Lambda is a function as a service where you only pay for that execution of the code execution duration, right? You don't pay for the complete duration. You only pay for how much time your code is being executed, and you don't pay for the rest of the duration, right? In such a case, you have your provisioning. What the technology that goes behind Lambda is, when your code is executing, what AWS Lambda does is it quickly brings up a lightweight container. Okay, in fact it uses something called Firecracker in it. Okay, Firecracker is again an open source. If I just go to Lambda, let me just play this video. But before I play the video, I'll quickly explain. So now what happens is, when you have Lambda, this is where your Lambda runs, where you write your code, you upload it to Lambda. And when Lambda is an event based um, model, where it gets triggered based on an event, right? So there has to be an event for your Lambda to get triggered. Like for example, excuse me, you have uh, you are basically you're building a social media website. Okay, you're meeting a social media um, app. So now when somebody uploads their picture, correct, like somebody is taking a selfie or uploading a picture into the social media website like Facebook. So what you want to do is, before you publish it, you want to ensure that you scan that picture, right? And then you scan the picture, and then you want to ensure that the picture adheres to the policies that your company has, right? You don't want anybody to just post any random pictures, right? Because you have a set of policies, and you want to scan the picture's content to see if it is okay and if it is acceptable by the company's policies. Okay, in such a case, you want to ensure that you run a image recognition code on the picture, right? And you've built a code, which quickly takes the image. It applies a machine learning model on top of the picture to see whether the picture conforms to the company's policy, right? That's a code that you have written. So now what you can do is you can build a Lambda function which takes a picture as an input, and then it runs the code, and then it tells you whether the picture is okay to be uploaded or not, or reject the picture, right? All this have to happen in the real time, right? You can't wait for 10 minutes, you can't wait for 15 minutes. It has to happen in a few milliseconds. So in such a case, it is an event, correct? The moment as a user, I upload a picture, the picture might go into an S3 bucket. So what your Lambda function would do is Lambda function would get triggered the moment it receives a S3 bucket, moment the S3 bucket receives a object in it. So in such a case, you can run a Lambda function. The Lambda function will run for 50 milliseconds or 100 milliseconds. It will quickly take the picture, scan the picture, and it will say whether it is okay or reject. So it's an event driven model, okay, where you can use it to respond to any type of events behind the scenes, right? So if you see, that's where if you see AWS Lambda lets you run code without provisioning or managing servers. In this case, you are not managing any server. You're taking your code. Lambda has a console, like in AWS console. You can go to Lambda and you can upload your code in the console, or you can type your code there itself, then and there. And then you can, when you run the code, what happens is behind the scenes, AWS provisions the necessary infrastructure for you, and then it executes the Lambda function, and it gives the results back to you. So it's called function as a service. So we have seen infrastructure as a service, platform as a service, software as a service, right? But you have something called function as a service, where you are writing a function, which you're writing a small software function, and that function is running as a service. Okay, your entire software can run as a service on top of your functions. Okay, that is the advantage of Lambda functions, right? With Lambda, you can run code for virtually any type of application or backend service, all with zero administration, literally zero administration, right? Because you're not exposed to your Apache web servers, operating system, compute, or virtualization layers, right? All of that is taken care by AWS. You only have to focus on your code. You only write your code, upload the code into Lambda, and run the code. It just runs, and you don't care whether which operating system it is running on, what middleware it is running on. Nothing of that sort is required. So, which means that you're also spared of the headache of patching your Windows, patching your Linux. Like in our case, last week when we all did the projects, we had to first use yum update hyphen y, correct? Why did we do that? Because we were updating the software in that particular EC2 instance, right? Without updating the software, you're exposed to vulnerabilities, correct? So you want to ensure that you keep your EC2 instance patched all the time, right? Similar to how you do it for your laptop, right? Or your mobile. It's where whenever Android or iOS releases new versions of software, you want to update your phone with new versions of software, right? Why do you want to do it? Because your older version might have some security vulnerabilities. So you want to end up avoiding end up being in a you want to avoid end up being in a situation where your phone gets hacked because of those vulnerabilities. Somebody is exploiting your vulnerabilities and somebody is hacking your phone, right? Whereas in this case, you don't have to worry about anything, right? AWS takes care of this whole thing. Just upload your code and Lambda takes care of everything required to run and scale your code with high availability. You can set up your code to automatically trigger from other AWS services, or call it directly from any web or mobile app. That is also possible. Uh, and uh, in this case, let's say, for example, your code takes 50 milliseconds to execute, right? And suddenly there are 1,000 hits coming to your application. So what AWS does is it automatically scales. Okay, it automatically scales the underlying infrastructure that is required to support 1,000 hits per second, or 1,000 hits per minute, or a million hits per minute, right? It automatically scales. You don't have to do anything, right? You don't have to worry about keeping the entire application up and running. Okay, that's the idea of using Lambda functions. Okay, so let's watch a small video about Lambda function, and then
when you're building applications, you want them to deliver a great experience. When you're building applications, you want them to deliver a great experience for your users. Maybe you want your application to generate in-app purchase options during a gaming session, rapidly validate street address updates, or make image thumbnails available instantly after a user uploads photos. To make this magic happen, your application needs back-end code that runs in response to events like image uploads, in-app activity, website clicks, or sensor outputs. But managing the infrastructure to host and execute back-end code requires you to size, provision, and scale a bunch of servers, manage operating system updates, apply security patches, and then monitor all this infrastructure for performance and availability. Wouldn't it be nice if you could just focus on building great applications without having to spend lots of time managing servers? Introducing AWS Lambda. AWS Lambda is a compute service that runs your backend code in response to events such as object uploads to Amazon S3 buckets, updates to Amazon DynamoDB tables, data in Amazon Kinesis streams, or in-app activity. Once you upload your code to Lambda, the service handles all the capacity, scaling, patching, and administration of the infrastructure to run your code and provides visibility into performance by publishing real-time metrics and logs to Amazon CloudWatch. All you need to do is write the code. AWS Lambda is very low cost and does not require any upfront investment. When you use AWS Lambda, you're simply charged a low fee per request and for the time your code runs, measured in increments of 100 milliseconds. Getting started with AWS Lambda is easy. There are no new languages, tools, or frameworks to learn. You can use any third-party library, even native ones. The code you run on AWS Lambda is called a Lambda function. You just upload your code as a zip file, or design it in the integrated development environment in the AWS Management Console. Or you can select from a list of function samples pre-built for common use cases such as image conversion, file compression, and change notifications. And built-in support for the AWS SDK makes it easy to call other AWS services. Once your function is loaded, you select the event source to monitor, such as an Amazon S3 bucket or Amazon DynamoDB table, and within a few seconds, Lambda will be ready to trigger your function automatically when an event occurs. With Lambda, any event can trigger your function, making it easy to build applications that respond quickly to new information. To learn more about AWS Lambda, visit our website and you can get your first Lambda function up and running with a few clicks in the AWS Management Console. And with the AWS free tier, you can try Lambda for free.
yeah, so that's Lambda, right? So where you saw that, I mean, you don't have to really manage any infrastructure, you don't have to manage servers, you don't have to do anything of that sort, right? I mean, everything is taken care by Lambda functions, and it scales automatically, and it also provides you a sub-second metering, right? So where, like if your code runs
Sir, your voice is low.
okay, sorry, I'm sorry. Yeah, so is it okay now? Yeah.
Yes, sir.
Okay. So yeah. So what I was saying is, we all saw about what a Lambda function is. It's basically a compute service where you don't have to worry about the underlying infrastructure. AWS takes care of spinning the underlying infrastructure, and you choose the language of your own, which you're aware of, like Python, Java, C Sharp, Go, Node.js, and things like that. And then you only pay for how much time your code runs, right? Like such as if your code runs for 100 milliseconds, you only pay for 100 milliseconds, right? So that's where you have no servers to manage. It scales continuously, sub-second metering, and gives you consistent performance, right? Whether you run 10 times the code or if you run 10,000 times, doesn't matter. Okay, AWS takes care of the uh, concurrency and provisioning the necessary infrastructure required to run your code. Like these are some of the use cases where data processing, right? You can use Lambda functions to process the data, right? When you get data, you can use it to process in an event-driven model. Real-time file processing, right? So you get files coming from multiple different sources. AWS Lambda can, I gave an example of S3, correct? Where S3 bucket is receiving objects. You can use Lambda to process the files that are coming into S3. Either it can be compressed or either it can be scanned for content, okay, and accept or reject those images or anything for that matter, right? It's up to you to decide how you want to go about. So these are some of the examples of what people have built using AWS Lambda. Okay. Yeah, and also there's a reference architecture that's available. I'm going to give you all of this, right? So there's a Git full of uh, reference architectures and sample code, right? You can just use this to straight away go ahead and build your applications. Okay, so that's about Lambda, and some features about Lambda is again a serverless compute service that runs your code in response to events and automatically manages the underlying compute resources for you. You can read about this. Yeah, this is very, very important. Bring your own code. With Lambda, there are no new languages, tools, or frameworks to learn. You can use any third-party library, even native ones. You can also package any code, frameworks, SDKs, libraries, and more as a Lambda layer and manage them and share them across multiple Lambda functions. Lambda natively supports Java, Go language, PowerShell, Node.js, C Sharp, Python, and Ruby. Okay, these are the uh, and provides a runtime API which allows you to use any additional programming languages to author your functions. Okay, and it's completely automated. You don't have to worry about failures of underlying infrastructure, because if momentarily what Lambda does is it brings up the code, it brings up the infrastructure required to host your function and host your code. Okay, so momentarily it brings up a new container and then it runs it in whichever infrastructure which is there. It brings up the function and then it runs the code. So that way you don't have to worry about a certain EC2 instance not working or tying the dependency on a specific EC2 instance. And also you can connect to shared file systems using Lambda. Yeah, so these are some of the features. Let's go to the pricing. Yeah, with the AWS Lambda, you pay only for what you use. You're charged based on the number of requests for your functions and the duration, the time it takes for your code to execute. So Lambda counts a request each time it starts executing in response to an event notification or invoke call, including test invokes from the console. Duration is calculated from the time your code begins executing until it returns or otherwise terminates, rounded up to the next 100th millisecond. The price depends on the amount of memory you allocate to your function. In the Lambda resource model, you choose the amount of memory you want for your function and are allocated proportional CPU power and other resources. Like you only allocate memory. You say that, okay, I need a 500 MB of memory for my code to run, or I need 1 GB of memory for my code to run. When you allocate memory, the proportionate CPU is also allocated automatically, right? You don't have to worry about the CPU. Okay. The AWS Lambda free tier includes 1 million free requests per month. So when you build your lab functions, like whatever we are going to do for the rest of the week, the project, you get about up to 1 million free requests per month and 400,000 GB seconds of compute time per month. Okay, which is quite huge, right? I mean, you can use it. I mean, you can run an application full month and still not get charged by AWS. Okay, which is a huge thing, right? 1 million free requests per month and 400,000 GB seconds of compute time per month. So that's the way to calculate it. Okay, this is basically an example. So if you see, for example, this is an if you allocated 512 MB of memory to your function, executed it 3 million times in 1 month, and it ran for 1 second each time, your charges would be calculated as follows. Okay, this is the monthly compute price. Total seconds is about 3 million seconds or 30 million seconds. Yeah, and then you have your total compute is about 1.5 or 15 million GB seconds. What you're charged is $18. Imagine the same thing. You have to use an EC2 instance. You have to keep it run. You have to keep your EC2 instance running for 24 hours, right? It will be much higher than $18. In this case, just $18 is nothing, right? Whereas in the case of EC2 instance, it would be probably 100 plus dollars, maybe 4 times, 5 times higher than what Lambda functions would give. Okay, so these are some things that you can look at. There's something called provision concurrency. It's a new feature, so you can enable provision concurrency for your Lambda functions for a greater control over the performance of your serverless application. Provision concurrency keeps your functions initialized and hyper ready to respond in a double-digit milliseconds. So what happens is there's something called cold start problem with Lambda, right? The first time when the Lambda function runs, or the first invocation to your application or the Lambda function takes slightly longer, because what AWS does is it provisions the underlying networking components, and then it provisions the underlying infrastructure required for running the Lambda function. So that's why the first invocation is always slightly longer. Subsequent invocations that come are not that longer, because infrastructure is warm up and running. So it comes and it just runs the code and gives the results back. Um, Whereas if you want your first call also to be respond back in a much faster time, there's something called provision concurrency, where it keeps your functions always initialized and hyper ready to respond in double-digit milliseconds. Double-digit millisecond is anywhere between 1 to 99 milliseconds. Okay, you pay for the amount of concurrency that you configure and for the period of time that you configure it. Okay, so that's where for example, you are building an application for a university. Okay, where the results are announced in a website, correct? And on the day of results, that people will be hitting it. Thousands of students would hit your website, and there will be several requests coming to your website. In such cases, during that time, you can have provision concurrency enabled, so that when students log into your website and when Lambda functions get invoked, they don't have to wait. They can scale. Like, this is a typical use case, right? I mean, all of us, so all of you who have come from universities, and when the results are announced, you see that the website crashes on the day of results. In fact, that happens even with national entrance tests like NEET and JEE and things like that, correct? Yeah. So yeah, so that's basically, and then you can also use a calculator, right? You can use a Lambda function, include free tier. Uh, you just put in your details, and then it will tell you how much time. Let's say I will have about 3 million requests, right? Or 4 million requests. And duration of request is like, say, 120 milliseconds. or let's say 500 milliseconds. Amount allocated is, I'll say 1024 MB, which is 1 GB. So I'll be paying only like $27 for like 4 million requests. If I increase 4 million to 40 million, so I'll be ending up paying $334. Whereas if I reduce the 500, if I optimize my code further so that my code runs only for 100 milliseconds, see, I end up paying much less. So that way, it all depends on, as a developer, how optimal your code is. You have to ensure that you don't waste so much of compute in your code, right? Unlike if you're running it on EC2 instances, or if you're running it on your on-premise, usually people don't care, right? I mean, they just make all costly operations in the code. Correct? When I say costly operations mean it uses a lot of memory, it uses a lot of CPU compute cycles, like string operations, right? How many of you have done string operations? You know that the moment you get into string operations, you will end up using a lot of compute power, and you will end up using a lot of memory. Okay, so that way you are optimizing on all of that, and you're ensuring that you're not spending so much on compute. Okay, as usual, you can get started with Lambda function. There's something called hello world tutorial. Build your first Lambda function. These are some cool resources that are available. And there are some tutorials that are available. Complete serverless web application tutorial. Reference architectures are available. Data processing. How do you process a file? How do you process a stream data? Like you're getting a stream, correct? Where you're getting some data streamed from some third-party system. Like for example, in a factory, in an industry, you have some devices, IoT devices, and that IoT devices is continuously streaming the health of your equipments every second, or every 10 seconds, or every minute, or every 5 minutes, right? In such case, how do you use Lambda to take that event, process that, and use it for your uh, and then build Lambda functions around that to process that data. Mobile backend, right? If you're building a mobile app, you need some backend for that, right? Where you want to process the data. The mobile backend can be a Lambda function. And edge computing, I'll come to that bit later. Yeah. Okay. So if you just click on this build your first Lambda function, it's just going to take you to a small tutorial with which you can build a small Lambda function and execute the Lambda function. Okay, we're going to do that slightly a bit later. Just hang on there. We will follow this hello world tutorial to build our first Lambda function and execute it. It's a small hello world function. Okay. Okay. All right. So let's come back to this. But in the meantime, I want to cover a few more things, right? Fargate, AWS Amazon Fargate is again another compute service, which is a serverless service where, I spoke about containers some time back, right? So where you have Docker containers and you use ECS or EKS. ECS is a Elastic Container Service that AWS has built, with which you can deploy containerized applications on AWS, where ECS uses EC2 instances underneath it as the compute nodes, and EKS is also there. EKS is Elastic Container Service for Kubernetes, where if you have a Kubernetes and you want to uh, run your applications in a Kubernetes cluster, you can use EKS. You can just provision. It's a complete managed service where the control nodes of Kubernetes is managed by AWS. You don't have to manage it. AWS manages it. So Fargate is basically a service, serverless service, where for ECS or EKS, you don't need to use EC2 instances. If you use EC2 instances, you have to manage the life cycle of that EC2 instance, such as patching and things like that, health of it and things like that. Whereas with Fargate, uh, Fargate is a managed compute service mainly for containerized services like ECS and EKS, where the underlying nodes, the compute nodes that are required, are managed by AWS. You don't have to manage it. That is called Fargate. Okay, then when you start building applications on cloud, you also have to integrate the applications with other third-party systems, other external systems, or other applications within your environment. Correct. So you need ability to integrate multiple applications together, right? So that's where you have a bunch of components in AWS which provides you integration services. There's something called Event Bridge. In Event Bridge, you can use an event bridge to build an event driven architecture that connects applications from multiple third parties, such as software as a service or your own applications or other AWS services, right? For example, I gave you an example of, okay, let's take weather service, right? You're building an application, mobile app, which takes the feeds from weather service, and then it tells you, it predicts, when is a cyclone going to come, or what is the uh, and then it uses that to alert your consumers, right? In such a case, you can use event bridge to integrate the events from multiple different sources. Step functions is a um, so how many of you know what a state machine workflow is? Raise your hands. State machine workflow. Okay. Okay, what is a workflow? Simple, in simple terms.
It's a series of actions, workflow means.
Yeah, excellent. So it's a series of actions, right? So it's a series of actions. I'll give an example, right? So you're applying for a loan in a bank. Okay, you're applying for a car loan or a housing loan, right? So what you do is you first go approach the bank. The bank would give you a form. You fill the form. You submit that form back along with all the necessary documents and everything. Then the form goes for multiple reviews and multiple levels of approvals. Correct. So internally, what happens is the bank does a work, creates a new workflow, right? So where the form goes to the loan officer who's processing your document or your application. From there, it goes to the legal team. The legal team takes the form. They look at the property. They look at the legal documents, such as whether the property is under litigation or not. Once that is cleared, so then it goes to uh, the uh, the valuation team, right? So then the valuation team takes it. The valuation team checks the value, property's value against the market rate, and then they determine the loan amount. Then from there, it comes back to the loan officer who's processing your loan. Loan officer reviews everything, and then he sends it for an approval. He sends it to the branch manager or the general manager for approval. Then it goes to the general manager. General manager takes a look at it. Finally, he approves it, right? So this is basically a series of steps. So now, even in applications, you need to you will have you know a need for orchestrating your code and orchestrating your functionality with a series of steps. That's called workflow. So AWS Step Functions is a service. It's a serverless service with which you can build workflows, real-time workflows, and with state machine workflows, which can wait for approvals and which can basically uh, take from one step to another step, and which can pass the inputs from one step to another step and things like that. SQS is called Simple Queue Service. Queue, queuing is a very common thing that we see all the time. Correct. Uh, any place that you go, there's a queue, right? I mean, if for people who follows that and people who are disciplined enough to follow the queue system. But queue is something that we've always seen all the time, right? Where you have a queue and then you just process. It's like first in first out, right? I mean, if you have read about data structures, you would have come across first in first out. That's called the queue. Linked list, linked list queues, stacks, right? You all of us have studied about that in our colleges, correct? Schools and colleges, data structures. Stack is first in last out, last in first out, whereas queue is first in first out. So you want to, you're receiving a lot of, say for example, I'll give you another example. Okay, you're building an application which has to send SMS to your consumers, correct? So when a person performs an action, you want to send SMS to that person, right? So that SMS service only has the capability to process 100 SMS in a minute. Okay. Now, if you push more than 100 SMS, it will fail because that SMS service cannot handle more than 100 SMS per minute. So in such a case, what you do is you don't push 1000 SMS to that service where you're sure that 900 SMSs would fail and only 100 would be processed. In such a case, you push it to a queue where it goes into a queue, and then the queue will send it to the SMS service in a batches of 100, 100, 100. Okay. So that's where you have the ability to decouple your application so that you don't fail. Okay. Failure is the least thing that everybody wants, right? You don't want your application to fail. Rather, you use a queue. Queue is a very decoupled way of uh, sending traffic to a destination, right? I mean, you take any, I mean, you go to temple, right? I mean, go to Tirupati temple. There are so much of queue, right? Where you have those cabins and they make you wait in the cabin, 100 people, 200 people, and then they send them in queues. Imagine all 1 lakh people barging into the temple premises, into the sanctum or near the sanctum at one time, right? So that's not going to be possible, correct? So queue system was basically to streamline the traffic and decouple so that things don't fail. That's SQS. So where SQS gives you an ability to create a queue, and then you can that stores and receives the messages at any volume, and then it sends it like how they do in Tirupati, right? Where they have those cabins where 500, 400, 500 people are made to wait, and then once they open the queue, the people go in a queue and then have darshan, right? So that way. Queue is like common everywhere, right? So queue is also a very, very important topic. SNS is a notification service. All of us did SNS, where you can send notifications, email notifications, SMS notification, PubSub. PubSub is publisher subscriber pattern. Okay, it's a design pattern where I'm the publisher, and if you want to subscribe uh, to my content, you subscribe to it, and but I'm publishing, so I'll basically broadcast to all the subscribers who have subscribed to my topic. It uses a PubSub pattern where you can send and get reliable high throughput SMS, email, and mobile notifications, push notifications, right? Mobile notifications, right? So for example, you have several apps installed on your mobile. Not all app uses SMS to communicate with you, right? You get a notification in your mobile app itself. So how is that mobile notification coming? It's coming through such a pattern, publisher subscriber pattern. So where there is a mobile push, notifications are there and it directly pushes it to your mobile. API gateway. Okay, API gateway is another important topic. We are going to in fact use API gateway, SQS, uh, Lambda, DynamoDB, uh, yeah, S3, and all of that in our lab later today, later this week in our project. API gateway is a way where, I mean, we live in the world of APIs, right? So where APIs are nothing but application programming interfaces. We all know what an API is. We have used APIs. We have used the APIs even for AWS, correct? So now when you want to consume some data or when you want to expose some data, you use the API, you build build APIs or you consume APIs, right? So there, what happens is API gateway is a service which can interface with your Lambda functions or with your microservices, and then which can give you an ability to uh, publish and securely manage the scale of APIs that are the scale of requests that are coming to your APIs. It's like a gateway. Okay, so where the gateway allows you to pass through securely, right? I mean, again, let me take the example of uh, Tirupati, right? So where in Tirupati temple, you have a entrance, right, to enter into the place where you enter the queue, correct? Where there's a big hall, and then they s- search you, they scan you, and then they see if you don't have any dangerous articles with you, right? And then they finally let you in, correct? And then they also validate your identity, correct? You have to show your some form of identity, and then they allow you inside, correct? So imagine an API gateway to be something like that, right? I mean, it's like a service which maintains, monitors, and secure the APIs at any scale. That itself is not serving the APIs. Rather, there is a Lambda function or something else which is actually running the code and serving the APIs, but this is just a gateway to enter into the Lambda functions or the other APIs that you have. Okay. App Sync is again a service which will uh, which with which you can combine data from multiple different sources, and then you can build flexible APIs to access your applications. Data store, right? So these are all for application integration. So then you have data store. S3, all of us know what an S3. In serverless architecture, S3 is inseparable, right? I mean, you have to use S3, or it's better you use S3 so that you can make better use of the entire serverless architecture. DynamoDB is a NoSQL key value pair database. It's a single digit millisecond performance at any scale, correct? So it responds back in less than 1 millisecond. Then you have Amazon RDS proxy. All of us know what an RDS is. RDS proxy is basically a proxy service for exposing your RDS for your serverless architecture and things like that. So it's where you can create a proxy, and this will act as a proxy between your consumer and the database, RDS database. Aurora serverless is, again, Aurora is a database, correct? I mean, RDS Aurora, correct? Serverless is again, you don't have to worry about the underlying infrastructure. If you choose for an Amazon RDS Aurora serverless, AWS takes care of it, and it can scale as per your application needs. Okay, so these are some of the use cases. So let me just go to web application. So here in this case, this is a reference architecture where you have your devices. Route 53 is your DNS service. Cognito. Okay, Cognito is also an important service where Cognito allows you to use uh, create a authentication and authorization, mainly authentication, right? So, for example, you're building a mobile application or a web application, and you want users to get user ID password, correct? Or you want users to use their social sign-in. What is a social sign-in, right? Using Facebook or Twitter or Amazon or Google, correct? You want users to use a social sign-in. A lot of applications do that, right? I mean, you have a Facebook or a Google account, you can log in using a Google or Facebook account, correct? So that way, you have your Cognito allows you to create a user pool, right, and provide authentication services in a serverless fashion. So then it goes to a API gateway. API gateway interfaces your Lambda functions. Wherever you see the Lambda symbol, that's a Lambda function. This is an API gateway. You have a bunch of Lambda functions interfacing with API gateway, and they are each Lambda function is, this is to add to do, this is to complete to do, this is delete, this is get all, get, update. You have about 6 Lambda functions to perform each function. of CRUD operations, and then you have your table, a DynamoDB table behind the scene, which is persisting the content and storing the content. So your Lambda function talks to the DynamoDB, fetches it, sends it to API gateway. API gateway sends it back to devices. Devices can use Cognito to authenticate. Okay. Again, Amplify is a new service where Amplify, uh, provides you a quicker way to build applications, web applications, and manage the lifecycle of those web applications. AWS Amplify. Okay. Anyways, you don't have to worry too much about AWS Amplify at this point in time. That will be a deviation from the topic. That's why I'm not explaining more about it. But yeah, if you have interest, you can just go and explore Amplify later. But these are the important things where uh, API gateway, Lambda functions, DynamoDB, S3. Okay, data processing. Let's see how data processing works. If you see data processing, let's say you're having a source S3 bucket. S3 bucket is getting some objects. The moment an object comes to S3 bucket, you trigger a SNS notification of the new object that is created in the S3 bucket. Okay, that goes to a queue. There are two queues here. One is for conversion, the other one is a sentiment analysis. Sentiment analysis is something like whether the object that is coming here or the content that is there, is it an appropriate content or not? Okay, if it is something, the content which is not appropriate, you reject that content. So you have a sentiment analysis SQSQ, which checks the sentiment analysis. There's a Lambda function and there's a DynamoDB. And then you have a conversion queue, which can take that and which does a HTML conversion, and then it outputs it into another S3 bucket. Okay. Uh, if it is failed, then it basically sends a dead letter queue to an SNS notification, and a CloudWatch alarm is triggered. Similarly here, and then finally you have something called comprehend also. Comprehend is an AML service. But yeah, forget about that part. Focus on this part where you have a DynamoDB, you have S3, Lambda functions, you have an SQS queue, okay, which queues the messages that are coming to it, and then it sends the messages to Lambda function, and you have a source S3 bucket. This is a data processing example, real-time file processing. Similarly, you have batch processing. Okay. If you want to build batch processing where you're getting batches, right? Suddenly you get some million records and you have to process that million records, right? How do you process it? Right. So this is basically an example of it where you have two S3 buckets. Uh, you build a step functions workflow uh, and with a bunch of Lambda functions. And then you run that Lambda functions within that step function where the step function workflow runs for that batch, and then it gives the results in an intermediate bucket, and then it stores the results in a final bucket, final output bucket. Event ingestion, right? Where event ingestion is like an IoT example where you have events coming from multiple different, say, devices. I mean, probably in an IoT scenario, right? You're taking those events and you're processing those events, right? So for example, in this case, there's a documents bucket which is getting PDF, document, JPEG, and everything. You're using a Lambda function using Amazon recognition. Recognition is a service that can recognize images. Okay, where it goes, if it is a text file, then it goes to a staging bucket. It splits the files and then it sends it to the queue bucket. If it is a JPEG image, recognition is a service. I'll show you recognition. AWS recognition. It's cool. It can recognize the subjects in the image in videos. See, it takes an image and it tells you this is rock, this is a person, this is a crest, these are outdoors, this is a mountain bike. Okay, and if you see this one, It basically recognizes that these are dogs, and it can also have custom labels, right? It's basically an image recognition service. Yeah, and if you see this text detection, right? I mean, you're running a marathon, okay? Some 10,000 people or 1,000 people. You're getting video feeds from the event, and you want to run a machine learning algorithm on the video feed to see, who's leading in the marathon, right? So you have the tag uh, in the marathon, right? You want to basically use that tag to identify who's coming fast, right? So this way, text detection within videos is a very, very powerful use case. Face detection and analysis, right? So where you give a picture, it tells you whether it's male or female. So in this case, it's 100% female is the algorithm that has decided based on the features. Eyes are open 100%. She is happy 97.4%, and she is also smiling, right? And then face search and verification, right? So you have face verification, right? I mean, in fact, iPhone also has got the face ID, face verification, right? So you want to verify based on the face, based on the dimensions of somebody's face, and to determine who that person is. It's used in forensics, and it's used in investigation and things like that, right? Celebrity recognition. It has a list of celebrities, pictures of celebrities. It can recognize which celebrity, what is his name, and things like that. Here in this case, Werner Vogels. Werner Vogels is the CTO of Amazon.com. Okay, he's a very powerful, he's a technologist, and he's a very, very powerful person, very knowledgeable, right? A very futuristic person. In fact, Werner Vogels has got a blog, right? If you're interested, you can just read that blog, Werner Vogels. His blog is called All Things Distributed. Okay, you can follow this blog. He writes pretty cool things, and there's so many videos about that where Werner Vogel talks about the technology roadmap of Amazon, right? And he also speaks about multiple things, right? I mean, you should view those videos. I mean, they're all quite interesting. In fact, there are videos about Werner Vogels and Jeff Bezos having chat with each other. Yeah, see, this video is really good. Werner Vogels, the secret behind Amazon's constant innovation, right? How Werner Vogels is how Amazon is able to constantly innovate.
Thanks, Roland.
Thanks.
Good to see you.
Good morning. If my voice falters now and then, it's because this London weather doesn't really agree with me. Yeah, so it's great to see that Beth actually also mentioned gatekeepers before. Yeah, so I think gatekeepers play a very important role, or not having gatekeepers plays an important role in driving innovation or enabling innovation in your company. Well, you already know who I am. So if you look at Amazon, is it 1995? E-commerce didn't exist. Yeah, and if you look at that all the way up in the left-hand corner, this is where Amazon was in those days.
Yeah,
You don't know whether you use
yeah, this is a
that.
nice video. I'll share the link of this video, or you can just search Werner Vogel is the secret behind Amazon's constant innovation. It's a very nice video. He talks about a lot of things. If you see this thing that he's talking about, the left one on the top, the first box that you see here, where I'm placing my cursor, this used to be the first website of Amazon.com books, because Amazon started way back in 90s as a bookstore, online bookstore, right? Yeah, and here you see this one. This is one of the Amazon's facilities. See how big it is, right? And data centers, and Amazon has got flights of its own. Okay, all right. I don't want to deviate. Let me share this later, or you can search for it. Okay, so let's go back, and this is like Werner Vogel's blog. You can read about it. Okay, so recognition service, it can recognize celebrities, personal protective equipment detection, right? I mean, in industries, or rather, now we are in a pandemic situation, correct? So in the pandemic situation, you get you want to mandate everybody to wear gloves and masks, correct? So you want to recognize if somebody is not wearing gloves and masks and flag that person. And you have a CCTV camera where you are monitoring every movement to your office in and out, right? So you want to catch hold of somebody who's not wearing. So you can use this personal protective equipment detection using recognition. Yeah, in fact, NFL. Okay, sorry, I'm just diverting a bit. I'll show you one more cool video about NFL. All of you know what an NFL is, right? It's a football league, National Football League. So using Amazon recognition NFL. Recognition. Okay, what is that video? Yeah. So if you see this, yeah. So this one, right? So this one and also this one. If you see AWS and NFL partner to transform player health and safety using AWS's machine learning services.
Ladies and gentlemen, please welcome Andy Jassy.
Thank you, guys,
Yeah. So
and
by the way,
thank you for coming. I appreciate it.
This was a reinvent video, right? And in 2019, in fact, I was there for this on in the Las Vegas for. I attended last year's reinvent, so I was there. So I actually watched this live in the auditorium. So this is basically about how AWS and NFL partnered to improve the transform the player health and safety using AWS's machine learning services, right? And using recognition services like SageMaker recognition and things like that, right? And comprehend and things like that.
It's been a great week here at reInvent, and we appreciate your spending some time with us today. So sports, to me, is an amazing
I'm
story
just going to
we had
forward
going.
it a bit.
Welcome to the stage, the Commissioner of the NFL, Roger Goodell. The last number of years, customer experience.
We have probability of a catch. We saw some of that up on the screen just before we started. And I think the fans have really taken to that, and our broadcasters have taken to, our media partners have been. Congratulations.
The NFL season is 17 weeks, 32 teams, 256 games, plus the preseason and the playoffs. That's over 50,000 plays, each one generating thousands of points of data. With AWS's machine learning, the NFL is analyzing that data like never before, with hopes of uncovering the insights that can lead to the innovations that can help make football better and safer than ever before. The same partnership already providing next-gen stats during the game will deliver even deeper learning by studying every aspect and every play from every game. With advanced machine learning, we'll analyze video and visual data in brand new ways. We'll simulate players and entire games millions of times, which will help us shape key elements of the game, including new rules, equipment, and rehabilitation and recovery strategies for players, as we aim to help predict injuries and intervene before they happen, and work to apply this new understanding of safety on the field to benefit people and industries off of the field. As football celebrates the last 100 years, the NFL and AWS are already innovating for the next 100.
Yeah, so that's a cool. Yeah, I'll also give
Good
you this
afternoon.
video. Right, you can just watch this. So yeah, just quickly see this. What is this?
Quality 34.
Super Bowl 52. As time ran down in the first, Nick Foles was about to complete one of the most improbable plays of the game. With each tick of the clock, AI from Amazon Web Services processed thousands of data points to generate real-time insights, proving that a 19% chance was all Foles needed to change the course of history.
Yeah, see, before even
Welcome to the next.
the game was played, I mean, the machine learning service was able to predict the outcome, right? So that's the okay. So yeah, so that's recognition. So that's what we were discussing, right? Recognition was being used here, where JPEG images are coming. Lambda function is using recognition to analyze the content. It's able to basically take it forward. That's event ingestion. Okay, so these are all some of the use cases and some of the examples of serverless computing, right? And can just get started here. And you also have something called SAM, serverless application model, right? Serverless application model is basically a set of framework. It's an open source framework for building serverless web applications. So it provides you a lot of shorthand syntax to express your functions, APIs, and things like that. So you can just, with a few lines of code, you can just build a complete application and model it using YAML. I mean, it's declarative style. Okay, and it accelerates the ability of developers to build applications much faster. Let's quickly see this video.
Serverless applications do not require you to provision, scale, or manage any servers, letting you focus on rapid product innovation and delivery. AWS SAM is an open source framework for building serverless applications and makes it easier to build higher quality applications quickly. SAM provides a shorthand syntax to express APIs, functions, databases, and event source mappings. With just a few lines per resource, you define the application you want and model it using YAML. The SAM CLI provides an AWS Lambda-like execution environment that lets you locally build, test, and debug applications defined by SAM templates. You can use the SAM CLI to deploy your application. During deployment, SAM transforms and expands the SAM syntax into an AWS CloudFormation template. Because SAM is built on CloudFormation, you can also specify any resource using CloudFormation syntax in the same template. You can even use SAM CLI to debug your applications locally. Just invoke a Lambda in debug mode with SAM CLI and then attach a debugger to it. This enables you to step through your code line by line, see the values of variables, and fix issues like you would for any other service. After building and testing your application locally, you can use SAM with tools such as Jenkins or AWS Code Pipeline to build a deployment pipeline and automate your Lambda deployments. And with just 3 lines in your SAM template, you can enable traffic shifting to gradually shift traffic to a new version of your application. Once your application is deployed, SAM helps you debug production issues. Use the SAM logs command to fetch, tell, and filter logs for your Lambda functions from the terminal, or see an application-wide monitoring view on the Lambda console. This displays metrics for all the functions in your serverless application and any custom CloudWatch dashboards defined in your SAM template. Built an app using SAM? Publish it to the AWS Serverless Application Repository so others can use your app and leverage architectural best practices too. To get started, visit aws.amazon.com/serverless/SAM.
Okay, so that's serverless application model. Okay, and apart from that, there's something called CDK, Cloud Development Toolkit. Cloud Development Toolkit is also quite interesting. So it's important for you to learn the Cloud Development Toolkit, right? I mean, in the long run, right? And so using Cloud Development Toolkit, you can use the same language that you're using to write your application software to also build the underlying infrastructure. For example, if you're using Java as your application software, you can use the same Java to build the underlying environment on the AWS and deploy that environment in a seamless way, right? So that's Cloud Development Toolkit. it provides you, and it's a very it's futuristic, and cloud development toolkit will uh, is used more and more to automate the deployments of serverless applications onto AWS, right? And you can use cloud development toolkit to um, manage the whole life cycle of your applications. And there's something called serverless framework. Serverless framework is uh, again, it's an open source thing where it tells you what are the various different patterns that you can use, right? And how you have to build a pattern, right? And how do you go about using that pattern to make your to ensure that your best practices are there. Okay, it's primarily for Lambda functions and serverless components, and there are a few open source components as well, frameworks such as Chalice, Claudia, and things like that. And there's something called and also continuous integration and development in AWS. I think I spoke about this earlier. You have continuous build, continuous deployment, continuous delivery of software, right? So you have code commit, code pipeline, code build, code deploy, code artifact, stackery. So these are all some of the tools that you get to manage the build and deployment of your entire serverless architecture. Monitoring, of course, CloudWatch, we know. X-ray is another thing which is commonly used in uh, serverless architecture, where you use X-ray to instrument your code end to end and figure out how long the code is taking and things like that. AppDynamics is again a third-party tool. Datadog is also very famous. New Relic, Splunk, Tundra. So these are all authoring and development. SAM has got a CLI and this IDE toolkits that are available. Cloud9 is a cloud-based, as a browser-based IDE. Okay, complete browser-based IDE. I think I gave a demo of Cloud9 sometime back, I believe. It's a browser-based IDE with which you can start writing your code in the browser. You don't need to install any software on your laptop or desktops on your personal computers. Okay, so yeah, I mean, so what I want all of you to do today is, I mean, we're not going to do any hands-on now. I want all of you to understand this, read about this, and come back tomorrow. So tomorrow we're going to start with Lambda. Straight away we're going to, no theory tomorrow. It's going to be straight away we're going to start with Lambda functions. Okay, I'm going to give you these links and the links to the videos. Serverless. And then you can click on each one of this to view. Okay. So please Lambda. You can watch these small videos, right? So I'm not going to just give each and every link. Okay, I'm just going to let you do it yourself. Yeah, I'll also give you this blog for a later thing, not now. I'm just going to ping you, not in this, so that okay, I'm not able to paste it in the chat, but yeah, I'll just give it to Brother Sai Krishna. He will post it in the group.
Sure, I will.
Yeah. And then yeah, I mean, don't worry about this for now. We're going to do this serverless hello world tomorrow. Don't worry about it for now. Just follow this and go through each and every service. What's that small video which is there in all the services homepage, and go through this, go through these use cases. I think you should be good for today. Okay, so we'll regroup tomorrow again, and we will start with building our first hello world function. Okay, and then yeah.
Hey, good morning, everyone. Thanks for joining us here again today at.
This is also a nice video. You can just watch this video.
When you're building applications, you want them to deliver a great experience.
Yeah, so I'm just going to give you this. So for today, just follow this and read through the next 1 hour. It will definitely take next 1 hour to read through these. So I'll see you all tomorrow, and we can start with the hands-on with Lambda. Okay, cool. I've pasted it in the chat, so please download it and go through the content, go through the videos, try to understand, I mean, what it is, right? That's very important. Try to understand the essence of why a serverless architecture is important. Read through that. We'll come back tomorrow, and then we'll start with Lambda and API Gateway tomorrow. Tomorrow's topic is going to be on Lambda and API Gateway, and if possible, we'll also do DynamoDB tomorrow. Okay, and then Wednesday we are going to cover 2 more topics. Thursday and Friday is going to be the project. We're going to build a complete web application using Lambda, API Gateway, DynamoDB, S3, SNS. Okay. Okay, all right. Then I'll basically let you all go into your breakout rooms and continue with your reading. And I'll see you all tomorrow. Okay, thank you so much for attending today's session. Yeah, thanks, Sai Krishna. Thanks, mentors. I think we can allow them into the breakout rooms.
Sure, Anna. Thank you so much for
Sai
your
Ram.
now. Yeah, we'll open the breakout sessions now.
Sure. Thank you. Sai Ram, thank you.
Sairam, bye now. Hello, guys.
Bye.
I will be opening breakout rooms now. Please do join there. And let your mentors know if you guys have any questions or backlogs from the previous project. Make sure to finish the project before we start the next one.
Excuse me, this is 820.
Yes, ma'am.
I have a small question and I have a small doubt on that project.
Okay.